In this video, we are going to study about the concepts of CDMA, which is third module in wireless and cellular communication. Before going into CDMA, let us have a brief introduction on CDMA. What is CDMA? And then we'll study about the CDMA network and system architecture. And we will also study about the CDMA basics, CDMA channel concepts, CDMA system operations, and 3G CDMA throughout this module. Moving on further, let us first study about how the CDMA technique came into existence, what all the evolution took place before CDMA. Firstly, CDMA stands for Code Division Multiple Access. During 1980s, AMPS was a cellular telephone system, which a system employed in the United States. In 1989, the Telecommunication Industry Association, that is TIA, adopted the time division multiple access technique, using this technology as a radio interface standard that would meet the requirements of the next generation of wireless systems. But however, the Qualcomm, with the support of various players in the mobile wireless industry, developed an alternative interface technology that also met these requirements. In 1992, TIA took a resolution wherein which the CDMA was first commercially networked. CDMA networked commercially began operation in Hong Kong in 1995. Since then, CDMA systems have been used in both cellular and PCS bands extensively in US, that is United States, and throughout the world. CDMA has experienced very rapid growth and is predicted to continue this growth as one of the primary technologies for the eventually deployment of 3G cellular in CDMA. To begin with, let us study about the evolution of 2G CDMA. First form of CDMA to be implemented was IS-95, specified a dual mode of operation in the 800 MHz cellular band for both AMPS and CDMA. This first standard defined the mobile station and base station requirements that would ensure compatibility for both AMPS and CDMA operation. To begin with, here we can observe we have the single user per channel AMPS FDMA, where this stands for the first generation. IS-95A is the basis for many of the commercial 2G CDMA systems installed around the world. The IS-95A standard describes the structure of wideband 1.25 MHz CDMA channels and the operations necessary to provide power control, call processing, handoffs, and registration procedures for proper system operation. Besides voice service, cellular operators were able to provide circuit switch data service at 14.4 kilobits per second over these first CDMA. The next evolution was the evolution of 3G CDMA. CDMA 2000 CDMA 2000 is the term for 3G CDMA systems. CDMA 2000 was one of the 5 proposals the ITU approved for IMT 2000 third generation standards, as previously discussed in IS-95. CDMA 2000 is the wideband enhanced version of CDMA. It is backward compatible with TIA, or it is also called as EIA 95, and provides support for data services up to 2 megabits per second, multimedia services, and advanced radio technologies. The implementation of CDMA technology is to occur in planned phases, with the first phase known as 1 into RTT happening over a standard of 1.25 megahertz of CDMA channel. There are further the information about the CDMA 2000 and other 3DMA technologies we will be studying in the next coming slides. Moving on further, let us look into the CDMA basics first. CDMA is a multiple access technology that is based on the use of wideband spread spectrum digital techniques that enable the separation of signals that are concurrent in both time and frequency. All signals in this system share the same frequency spectrum simultaneously. The signals transmitted by the mobile stations and the base stations within a cell are spread over the entire bandwidth of a radio channel, encoded in such a way as to appear as broadband noise signals to every other mobile or base station receiver. The identification and subsequent modulation demodulation of individual signals occur at a receiver through the use of a copy of the code used to originally spread the signal at the transmitter. This process has the effect of demodulating the signal intended for the receiver while rejecting all other signals as broadband noise. Since a specific minimum level of signal to noise ratio is necessary to provide for a certain level received signal quality, the level of background noise or the interference from all the system transmissions ultimately limits the number of users of the system and hence system capacity. Therefore, these CDMA systems are carefully designed to limit the output power of each transmission to the least amount of power necessary for proper operation. At this time, the CDMA air interface scheme with the frequency division multiple access, that is FDMA, and TDMA air interfaces, the available radio spectrum is divided into. So we can see in this comparison of different techniques wherein which the AMPS, mm, the AMPS, we have this. So we have a single user here, we have the multiple users and the multiple users per channel. So we have at the CDMA 1 and CDMA 2000, that is 2G CDMA and 3G CDMA, we can see there are multiple users per channel. So as we look into this, the TDMA, that is the frequency, the user confines the transmitted signal power within this channel, and selective filters are used at both ends of the radio link to distinguish transmissions that are occurring simultaneously on many different channels. The frequency allocations can only be reused at a distance far enough away that the resulting interference is negligible. The TDMA scheme goes one step further by dividing up the spectral allocation in time slots. Now, each user must confine its transmitted spectral energy within the particular time slot assigned to it. For this case, the mobile and the base station must employ some type of time synchronization. This technique increases the spectral efficiency and spreads its transmitted energy, at the expense of each user's total data rate. In CDMA, each mobile has continuous use of the entire spectral allocation and spreads its transmitted energy out over the entire bandwidth of the allocation using a unique code for each transmitted signal. The mobiles and the base stations are able to distinguish between signals transmitted simultaneously over the same frequency allocation. CDMA can also be combined with FDMA, TD and TDMA technologies to increase the system capacity. Now coming to the CDMA frequency bands. So moving on further, we have let us study about the frequency bands, how the frequency bands are going to be selected for the CDMA. For 2G CDMA systems, one might be inclined to state that the frequency separation between the adjacent carriers or channels is 1.25 MHz. In CDMA standards, the terms carrier and channel are carefully distinguished from one another. A carrier frequency may be divided means of codes into 64 different channels. Each of these channels may carry information related to a separate and distinct conversation or data connection in digital form. This discussion would be, in TDMA systems, where each carrier is divided into time slots and each time slot serves a channel. In Now, coming to the CDMA frequency bands, in in this CDMA frequency bands, the 19,900 megahertz PCS band would be used for either GSM, NATDMA, or CDMA technologies. The NDT, NATDMA PCS channel numbers and carrier frequency for CDMA, it is with a 50 kilohertz, 150 kilohertz of channel spacing. The chart indicates a total number of 1,200 CDMA channel numbers. During this, how the planning issues are going to be, frequency planning issues are done. Because of a frequency reuse factor of n equal to 1, CDMA frequency planning is relatively simple compared to the analog cellular system. For a system that only requires one carrier per base station, that carrier must be chosen from the list, chosen properly. The same channel should be used by all the base stations throughout the system to take the advantage of soft and softer handoff capabilities that are possible with the CDMA technology. Hence, the frequency planning in the PCS bands becomes much more problematic if one considers inter-system issues. So, the three possible cases to consider here are: first, if the two systems are both CDMA, then geographically neighboring systems should not affect one another. The next one, the second system is either a NATDMA or GSM system operating in the adjacent geographic area within the same frequency block. And the proceed with the third one, and the third problem is nothing but the frequency coordination is again necessary in conjunction with the consideration of the type pre-existing service. Next, the CDMA network and system architecture. Moving on to the CDMA system architecture. In this, we can see the network and system architecture of the CDMA. So, the initial, as we have discussed already, we know the major how the frequency division or the frequency planning issues are going to be done with respect to the CDMA, if at all, and TDMA and FDMA are incorporated. Now, by looking into the major network components of a CDMA 2000 wireless system, we have the mobile serving switching center and the visitor location. So, mobile switching center. So, this one we can see here, the MSC and the VLR. The CDMA mobile services switching center serves as the interface between the public switched telephone network, that is PSTN, and the base station subsystem BSS. The MSC performs the functions necessary for the establishment of calls to and from the system's mobile subscribers. Coming to the internetworking function, the system's the internetworking function, that is IWF node, is the only gateway between the wireless network and the packet data network, that is PDN. Packet data network, PDN. As such, it provides a direct connection to the PDN packet data cells, packet data calls. Additionally, the IWF node supports circuit switch data cells calls by providing internal modems for connections to dial-up internet service providers. These circuit switched data calls are connected to the PSTN through the MSC. Toward the IWF typically uses Ethernet for the signaling between itself and the MSC and for the exchange of packet data between itself and the PDN. Next, knowing about the network components, let us move on for the So, moving on further, we'll look into the concept of PPS and PLMN subnetworks. Thank you. Hope this video is informative to you. Thank you.